How to derive the equation of an ellipse.
Maybe you know the equation of an ellipse, but do you know how this equation derive?
Here is an ellipse with x-axis as major axis, and if you draw lines from the foci to the upper co-vertex, these two lines is equal to the distance to the vertices on the major axis.
These two lines also forming to right triangle S with the minor axis. Let the distance from the center to the upper co-vertex equal to b.
And let's see the distance from the center to the foci.
Now, we have two similar triangles. So the length of the two lines are both square root of b squared plus c squared.
And if you make these lines horizontal starting the center to the two vertices on the major axis, you can have the distance of 2a. So 2 times square root of b squared plus c squared is equal to 2a.
Transpose to the right, making it a divisor. So square root of b squared plus c squared equals a.
Square both sides of the equation, so we have now b squared plus c squared equals a squared.
Transpose c squared to the right, so b squared equals a squared minus c squared.
This is a useful equation.
Let the first foci be f sub 1 with coordinates negative c, 0, and the second foci as f sub 2 with coordinates c, 0.
And let point P on the ellipse with coordinates x, y.
So the horizontal length from x to f sub 1 is x plus c, and the length from x to f sub 2 is c minus x.
And the vertical length is of point P is y.
Let the intersection of the major axis and ellipse or the two vertices be v sub 1 and v sub 2. The length is 2a.
We have length from the first foci or f sub 1 to point P plus the length of the second foci or f sub 2 to point P is equal to the length of the first vertex or v sub 1 to the second vertex or v sub 2.
From this equation, we can start deriving the equation of an ellipse.
Back to the ellipse. The length from f sub 1 to point P is obtained by Pythagorean theorem as squared root of quantity x plus c squared plus y squared.
And the length from f sub 2 to point is square root of quantity c minus x squared plus y squared.
Adding these two lengths is equal to 2a.
Square root of quantity x plus c squared plus y squared plus squared root of quantity c minus x squared plus y squared is equal to 2a. Transpose the second radical to the right.
Here, we can square both sides of the equation.
We can remove the radical sign on the left and use binomial square on the right. So quantity x plus c squared plus y squared equals 4a squared minus 4a times square root of quantity c minus x squared plus y squared plus quantity c minus x squared plus y squared. To solve this, easier cancel y squared by transposing y squared to the right.
Here we can cancel y squared as 0.
Use binomial square for x plus c and c minus x.
Here we can combine like terms by transposing x squared and c squared to the right and negative to cx to the left.
So 4cx equals 4a squared minus 4a times square root of quantity c minus x squared plus y squared.
Transpose 4a squared to the left.
And divide both sides by 4.
So cx minus 4a squared equals a times square root of quantity c minus x squared plus y squared, and square both sides of the equation. Use binomial square on the left and remove the radical sign on the right.
Use binomial square on quantity c minus x squared.
And using distributive property on the left side, so a squared c squared minus 2a squared cx plus a squared x squared plus a squared y squared.
Combine like terms.
So cancel 2a squared cx as 0.
So c squared x squared minus a squared x squared minus a squared y squared equals a squared c squared minus a to the fourth.
Factor x squared on the left and a squared on the right. Divide both sides by a squared times quantity c squared minus a squared. Cancel quantity c squared minus a squared on the first term and a squared on the second term equals 1. So x squared over a squared minus y squared over c squared minus a squared equals 1. Remember that we have this equation b squared equals a squared minus c squared. So negative b squared is equal to c squared minus a squared. So substitute this to c squared minus a squared on the second term and cancel the negative sign. So we have x squared over a squared plus y squared over b squared equals 1.
This is the equation of an ellipse with x-axis as major axis, where a is the length the center to vertex along the major axis and b the length from the center to the vertex on the minor axis.